Okay, so this is the problem. The intensity of illuminations at any point from a light source is proportional to the square of the reciprocal of the distance between the point and the light source. Two lights, one having an intensity 8 times that of the other, are 9 meters apart. On the line between the two light sources, how far from the stronger light is the total illumination list? First of all, we have to make sure that this is application of derivative problem, because you can see that we need to find out the list value. So list means minimum. We need to find the minimum. And in calculus class, if you have to find maximum or minimum value, then that means that's the application of derivative. So the first thing you need to understand in this problem is you have to create a function, and then we need to use the first derivative to find the critical points, and then after that second derivative to find out the minimum or maximum value uh, using the critical points. So in this case we are trying to calculate the intensity of illumination of the light. And there are two light sources. First of all, we need to understand, let's say I stands for intensity of light, intensity of illumination of light. Okay, intensity of illumination. And to understand about this first line, let's say there is a light source and you want to find out the intensity of illumination of this light at some point, let's say this point. Then according to this problem, according to the information we have given, the intensity of light at this point depends on the distance of this point from the light. So let's say the distance from the light to that point is x. So according to this problem, intensity of illumination at this point from this light is proportional to the reciprocal of distance. Whenever they say proportional, we have to introduce coefficient of proportionality. In this case we say coefficient of intensity coefficient. So let's say the intensity coefficient is c. C means it's a constant coefficient of intensity. C is constant, and which is a coefficient of intensity. So instead of having just one light source, in this problem there are two light sources, and we would like to find out illumination in between those two light sources. So in between, so make sure that other light source is another side of that point. So for example, if one light source is on left side of the point, then other light source may be somewhere here. Let's say this one. I'm drawing this light source as a smaller than this one, because in this problem we have given that one is uh, one having an intensity 8 times than other. Okay, so it has intensity uh, 8 times than this one. So if c is the coefficient of intensity for if we are going to use the c as a coefficient of intensity for both of the light sources, then when we calculate the intensity of illumination from this light, it will be c over the distance, square of the distance um, of this light from this point. So in this case, if you look at the problem, we have given that these two light sources are 9 meters apart from each other. So the distance from this light to this light is 9 meters. So in that way we can find out distance of this other light from this point is 9 minus x. So when we calculate the intensity to this point from this light, it will be coefficient of intensity over 9 minus x square. And because there is another light as well, so to calculate the intensity from this light would be 8 times the coefficient we use for this light over the distance x square. So eventually this intensity at this point will be combination of both of the intensity coming from both of these two sources. So for this particular problem, for this particular situation, the intensity I is equal to intensity coming from this light source, which is 8 times the coefficient I'm going to use for the another light source over the distance, square of the distance, plus coefficient for this source c over the square of the distance. Remember, this c is just a representation of intensity, coefficient of intensity. If c is the coefficient of intensity for the smaller light, then for the bigger light it should be 8 times c. Now this is the function, this I function. We need to find out the minimum value of this function. So we need to use the first derivative and second derivative test to find out for what value of x, where you can see that x is the distance of this point from the stronger light sources. So you can see that how far from the stronger light is the total illumination list. So the meaning is what should be the value of x such that this I would be the minimum. Okay, so how far, this is the x, from the stronger light, the total value of the illumination, which is I is the total value of the illumination, would be minimum. So to find out that, we use calculus. That means we use the first derivative and second derivative. So first of all, to use first derivative and second derivative or second derivative test, we need to find out the critical points. So we need to find out the first derivative, we need to find out the second derivative, we need to find out the second derivative, and we need to find out the critical points. And critical points can be found by equating the first derivative with 0. So find critical points, find critical points by doing I prime equal to 0 and solving for x. It will give you the critical points, and after finding the critical points, find out the value of the second derivative. Find the value of the second derivative of this function. Find out the value of the second derivative at critical points. So wherever this second derivative is positive at any critical point, if there is a positive second derivative at any critical point, that is the minimum value. That at that point we get the minimum value of the function. So that's the idea. Okay, so for that we need to find out the first derivative. We need to equate the first derivative to 0. We need to find out the second derivative, and we need to check the value of the second derivative at critical points, and we need to find out where that second derivative would be positive. That is the goal. Okay, so let's go to the next page. I already calculated this value for this function I, which is 8 times c over x squared plus c over 9 minus x squared. If you try to find out the first derivative of this I, this will be your first derivative. So I'm going to just show you. So the first derivative, we have to use the general power rule. 8 and c, they are constant when you would try to find out the derivative of 1 over x squared, it would be negative 1 over x, negative 2 over x cubed. And that 2 times 8 is 16. Same thing is true here. So let me just show you the derivative of 1 over x squared with respect to x is negative 2 over x cubed. Similarly, the derivative of 1 over 9 minus x squared, 9 minus x to the power 2 is negative. So you have to use the chain rule for that. So let me just show you the derivative of 1 over 9 minus x squared is negative 2 over 9 minus x cubed times the derivative of this inner function, which is negative 1. So eventually it will be 2 over 9 minus x cubed. So this is what I used here to find the derivative, and I used the very same trick to find the second derivative as well. Now this is very lengthy calculation, that's why I just calculated this in advance. To find out the critical point, just equate this first derivative to 0. So if you just simplify this thing, you can factor out 2c. Keep in mind, c is the coefficient of intensity of illumination. It cannot be equal to 0, because if that coefficient is 0, then intensity of illumination, for the light coming from those two resources would be 0. So this should be non-zero. Now to simplify this, I'm trying to make it the same denominator, and now after that I just combine these two rational terms, and then I'm going to get x cubed minus 8 times 9 minus x to the power cube on the top, and this thing on the bottom. Because the bottom part cannot be equal to 0, so I'm just equating the top part to 0. And now I'm using 9 minus x cubed equal this. Just multiply 9 minus x times 9 minus x times 9 minus x and simplify. This is what you are going to get. There is a 8 negative in front, so just distribute this negative 8, and this is what you get. And now there will be positive 8x cubed and positive x cubed. If you combine them, it's going to be 9x cubed, and you can factor out 9. And after you factor out 9, because 9 is not 0, so this thing must be equal to 0. And now we need to factor out this thing. So I just split this second term 24x squared into 6 and 18. This one to 16 into 108 and in 108. By doing that, I can find out the common factor x minus 6 and x squared minus 18x plus 108. If you try to solve this one using the quadratic formula, you are going to get the imaginary solution. So only real solution you are going to get is x equal to 6. So this x is equal to 6 is your critical point, and if you plug x equal to 6 back in this second derivative, this should be positive. Keep in mind, this constant of coefficient, this constant is always positive, because that's the coefficient of intensity of illumination. So because of that, this part would be always positive. Okay, I hope you did understand this problem. So this function I, intensity of illumination or illumination at this point would be minimum from the stronger resource if x is 6 meter. Okay, so that's the answer. How far from the stronger light is the total illumination least? The total illumination will be least if the distance of that point is 6 meter from the stronger light source.